Welcome to Math with Professor V. This is video lecture for section R.2 for business calculus on factoring. And this is just going to be a brief overview of your factoring techniques and strategies. But if you need more examples and a little bit more of an in-depth explanation, I'm going to link additional video lectures that I have on factoring, just in case you need a little more than what I'm going to go over here. So first factoring concept we need to go over is factoring out the greatest common factor. And you always do this first, regardless of what technique you're going to use subsequently. And sometimes it's done after this step. So for the first couple examples, we're just going to practice factoring out the greatest common factor. In this particular case, example A, I'm looking at 12x and 18. So what's the largest factor that I can take out from both of those terms? Well, all I can do is take out a constant because notice 18 doesn't have any variables on it. So then now you're just thinking, okay, what's the largest factor that both 12 and 18 have in common? And that's 6. So when you factor it out, you write the 6 out front, then you put parentheses and you divide each of the terms by what you just factored out. So 12x divided by 6 would be 2x. Keep that minus sign. And then 18 divided by 6 is 3. And you're done. And if you're ever nervous, you could always just verify your work by distributing that 6 back through, and you should get what you started with. All right, let's try one more. 6x cubed minus 9x squared plus 15x. So in this case, I can take out not just a constant, but a variable also. First, let's focus on the constants though. 6, 9, 15. What's the largest factor all of those three have in common? Just a 3, right? And then I'm looking at the variables, x cubed, x squared, and x. All I can take out is x to the first. I can't take out any more than what one of them has. So that's it. Just take out 3x. And then now what am I left with? So 6x cubed divided by 3x becomes 2x squared. Then we have minus 3x plus 5. Okay? And then just box it so that you know you're done. All right, that's always the first step. Then the next thing you need to make sure you can do with ease is factor a trinomial. Usually they're quadratic trinomials, meaning the first term is squared, the second term is going to be the variable to the first, and then we have a constant. So here for the following trinomial, x squared plus 7x plus 12, it's going to factor into x plus or minus something, and then x plus or minus some other constant. And the way I find these somethings is by looking at the coefficient of x here and the constant, this last term, 12. Your goal is to find two numbers that multiply to 12 and that add to 7. Because basically we're undoing the process of foiling or multiplying out these two factors here. So to organize your thought process, a lot of students like to make this little X, or some students have a different process that they've been shown in school before. If that's you, go with it. If it's working for you, more power to you, please. So we've got 12 up top, 7 down below, and then just think to yourself, okay, what multiplies to 12 and adds to 7? If you need to make a list, you can, but usually you can do it in your head. So 12 times 1, no. 2 times 6, no. 3 times 4, yes, that works. 3 and 4. So basically those are your little asterisks here. That's how this is going to factor into x plus 3 and x plus 4. And we're done. Now, the method is this straightforward as long as the coefficient here on that leading term, the squared term, is just a 1. We'll talk about what to do when it's not in just a minute, okay? Let's try another example. You can make the little x if you want or not. If you can do it in your head, good. We're all hoping to get there sooner than later. So can you think of two numbers that multiply to -5 and that add up to -4? So in this case, since they have to multiply to -5, the two numbers will have opposite signs. And then they need to sum up to -4. What two work? It's going to be -5 and +1, right? So then this factors into x minus 5 times x plus 1. And you could write the factors in the other order. X plus 1 times x minus 5, it's the same thing. All right, good. Example C a squared minus 3ab plus 2b squared. Now don't let this ab and b squared freak you out. For a minute, let's just pretend it's not there. Let's just pretend we've got a squared minus 3a plus 2. Ignore the b's. Ignore the b's. Could you factor that little trinomial? So can you think of two numbers that multiply to 2 and that add up to negative 3? It's just going to be negative 2 and negative 1, right? Okay, so then you set it up the same way. You're going to have a minus 2, a minus 1, and then since we want the last term to be b squared attached to the constant, I'm just going to put a b here. And then it's going to work out that the middle term is going to be minus 3ab, because watch, this is negative ab, this is negative 2ba, which is the same as negative 2ab. So altogether, boom, there's your negative 3ab. And of course, we don't have to put the 1 there. Good? Okay, so this is a pattern that you'll see, and it looks more intimidating than it needs to be, so don't worry. Now, I did say the process is going to be a little more involved when you're factoring a trinomial and that leading coefficient is not a 1. See, in this case, how it's a 3. So what we're going to do ultimately is factor by grouping. And to start off, we have to figure out what constants we're going to use to split the middle term. So this overall technique is sometimes called the AC method or splitting the middle term, etc., etc. And factoring by grouping is something that we do when we have 4 terms typically. So here's how the process works. You're going to make your same little x, okay? It's just that in this case up top, you don't put the constant c, you put a times c. A times c goes up top, and then b, the coefficient on the linear term, goes in the bottom. So remember, you have ax squared plus bx plus c. So a times c, that goes up top. The air conditioner is upstairs, and the basement is downstairs. Okay, so let's see. In this case, a times c would be 3 times negative 7, so that's negative 21. And then b is 4. So can you think of two numbers that multiply to negative 21 and add up to 4? Good. It's going to be negative 3 and positive 7. Okay. Once we have those two numbers, then I'm going to split the middle term. The middle term is 4x using these constants. So you don't go straight to the factored form when you're using this method, and that's because this coefficient here is not just a plain old 1. So watch how I'm going to split the middle term. I'm going to rewrite 4x as negative 3x plus 7x. So the negative 3 and the 7 are the two constants I found here. And then look, nothing illegal has happened. Negative 3x and 7x, that's 4x. I've just split it. And then keep everybody else where they are. So you still have 3x squared here minus 7 here. But now we have 4 terms, and we can factor by grouping. So when we factor by grouping, you just look 2 terms at a time, and you take out the greatest common factor from each pair. So 3x squared and 3x, I can take out a 3x, and I'm left with x minus 1. And then this plus sign comes down. I can take a 7 out of the next 2 terms, and then I have x minus 1. And as long as you did everything correctly, these remaining factors here should match. If they don't, then something went wrong earlier in the process. And now I can factor out x minus 1, and I'm left with 3x plus 7. Good? If you're not too comfortable with factoring by grouping, I'll link a video here. You can just click in the top right that goes through it, because you need to be pretty comfortable in order to apply this technique, okay? Let's look at some more examples. We have 4x squared plus 8xy minus 5y squared. So again, you can make your little x over here. And we put a times c, so 4 times negative 5, that's negative 20 up top. And then b, which is 8, goes in the bottom. So can you think of two numbers that multiply to negative 20 and that add up to 8? Good, 10 and negative 2. Perfect. So I'm going to use these constants to split up the 8xy as follows. We have 4x squared plus 10xy minus 2xy minus 5y squared. And then factor by grouping. So pair them up, take out the GCF. From 4x squared and 10xy, I can take out a 2x, and then I'm left with 2x plus 5y. And then from the next pair, see how there's a minus sign here? That's what I got to bring down. I can take out negative y, and then I'm left with 2x. Be careful. This is going to switch to plus 5y. Watch out. Because we factored out a negative, the sign switches here. So I'm going to put the little watch out eyeballs. That was a dangerous moment. But if you forgot, the good thing is, remember, these should always match. So you would be like, wait, why do I have a minus sign here when there's a plus sign here? So hopefully that'll remind you. Okay, and then perfect. 2x plus 5y can be factored out. And then I'm left with 2x minus y. And we're done. Good? Okay, I got one more. On this one, before you have a panic attack, we need to factor out the GCF first. That wasn't applicable in any of the previous problems. They didn't have a common factor, so I didn't take anything out. But these three terms, I can take out a 12, right? 12 goes into all of these. That's the greatest constant that can be taken out. And then I can also take out an x squared. So let's do that first. So take out 12x squared, and then you're going to be left with 2x squared plus 3xy minus 5y squared. Already, you should be feeling a lot better. So I'm just going to focus now on this trinomial and see how we're going to factor it. So a times c, 2 times negative 5, that's negative 10. And then b is 3. So can you think of two numbers that multiply to negative 10 and add to 3? Good, it's 5 and negative 2, right? So you just leave this 12x squared outside. Just hanging on for dear life. And then we've got 2x squared plus 5xy minus 2xy minus 5y squared. Beautiful. And then just keep rewriting 12x squared out there. Now I'm going to factor by grouping. So I can take an x out of both those terms, and I have 2x plus 5y. And then be careful right here. Bring the minus sign down. And then what can I factor out of the last two terms? Just a y, a negative y technically, right? So then this is 2x plus 5y. Good? And then perfect, these match up, so I know I'm on the right track. So then we've got 12x squared. You don't have to keep that, bracket outside the parentheses anymore, because this is going to be fully factored. 2x plus 5y times x minus y. And we are done. Okay, like I said, this was just the briefest overview, so if you want more examples and more slowed down practice and explanation, go to the description. I have so many other videos on factoring. Okay, last thing are special factorizations, meaning special patterns to be on the lookout for. So the first one is a difference of squares. So a difference of squares has the form a squared minus b squared, and it factors into a plus b times a minus b. Just so you know, a sum of squares does not factor, it's prime. A squared plus b squared, nope, doesn't factor, it is prime. Also, we have perfect square trinomials. And I'll show you what they look like. So we have two of them. One is a squared plus 2ab plus b squared. And that factors into a plus b quantity squared, which is the same as just a plus b times a plus b, but it's just a special case. And you can also have a squared minus 2ab plus b squared. The only difference is that factors into a minus b quantity squared. And then we have a difference of cubes. So a difference of cubes would be a cubed minus b cubed, and it factors as follows: a minus b, a squared plus ab plus b squared. And to help you remember how to factor this, you can use the mnemonic SOAP to keep all the signs straight. So I'll show you what SOAP stands for right now. Same, opposite, and always positive. So let me show you how to think of it. So since we were factoring a difference of cubes, we had subtraction between the original two terms. So this first factor just has two terms inside. It's going to have the same sign, minus sign. The next is opposite of what you had, and the last one's always positive. You just have to remember now the rest of the format, that it's AB, A squared, AB, B squared. But you can use this same idea to factor a sum of cubes. So sum of cubes just has a cubed plus b cubed. So first let's use SOAP to fill in the signs. So it's going to be same plus, opposite minus, last one's always positive. And then AB, A squared, AB, B squared. That's always the same. Okay, good. So those are the patterns that you need to just put to memory. And then keep in mind, on occasion, we'll run into things that don't factor. So if you have a polynomial and it can't be factored, you just say so. And don't feel badly about it, okay? It's called a prime polynomial. And that's pretty much it. So now let's practice using these special formulas. And again, I only have a couple examples, 4 to be precise. That's more than a couple, I suppose. But if you want more than 4, then you know where to go. Straight to that description box. Okay, factor 64p squared minus 49q squared. So I look, it's two terms, there's subtraction. It's either a difference of squares or a difference of cubes. It's a difference of squares, I can tell. So let's rewrite it as 8p quantity squared minus 7q quantity squared. And then this is going to factor into conjugate pairs. So 8p minus 7q times 8p plus 7q. And we're done. That's it. Good? Okay, what about x squared plus 36? Oh, that's a sum of squares, right? Okay, so that's prime. Doesn't factor. Nope. Nope, nope, nope. What about x squared plus 12x plus 36? That's actually a perfect square trinomial. It fits the pattern a squared plus 2ab plus b squared. So it's going to factor just into x plus 6 quantity squared. Look, this pattern tells you you square the first term. So once it's factored, you square the first term. You take the two terms, multiply them by each other, and then double it. So x times 6 doubled is 12, yep. And then you square the last term, b squared 36. If you forgot and you didn't notice that pattern, it's really not a big deal, because if you were to do our other method, you're sitting there going, okay, what two numbers multiply to 36 and add up to 12? Why, it's 6 and 6. So then you would maybe put x plus 6 times x plus 6 and then realize, oh, this is just a simpler way of writing that. Okay? Good. And then let's just practice one sum of cubes. So we have m cubed plus 125. So rewrite it first. It's m cubed plus 5 cubed. It's a sum of cubes. So I'm going to set the signs up. We've got the same sign, opposite sign. Last one's always positive. And then the pattern goes AB, so m5, a squared, so m squared, AB, don't write m5, that looks weird, 5m, and then b squared. So 5 squared is 25. And the nice thing is, this is going to be prime always, just so long as, if you have a difference of cubes, you have to factor it as a difference of squares first, if that's applicable, in order to guarantee this is always prime. But that comes up so infrequently. So we're done. All right, that concludes the factoring review rapid fire. So don't forget to subscribe, give the video a thumbs up, and then we've got one more review video before we jump into the actual course content. So stay tuned. I'll be back sooner than later. Bye.